First of all, I'm going to run through all of the elements of the game. Firstly, we have the start screen with the respective play quit options, which are made using the Unreal's UMG, also known as the Unreal Motion Graphics, and creating a widget blueprint. In the current state, the game is paused. When the play button is pressed, the game is unpaused and the game starts. As stated in the tutorial on the front page, the player can move their ship using the WASD keys and fire pressing the spacebar. This is the preview of the script that I have attached to the play button on the main menu. First of all, when it is pressed, the game is unpaused, highlighted by this blueprint node. Next, we make sure the mouse cursor is no longer showing, because we don't want to see that in game. We then remove all widgets, which removes the initial main screen GUI. I then create the new GUI using this blueprint node, which creates the new widget with my class in-game menu and then adds it to the viewport. This then begins the start of the game. The player's health is displayed on the upper left, alongside the player's score. Whenever an enemy is killed, 10 score is added. To get the enemies to spawn, I have a trigger volume that comes down at a certain velocity, which comes and collides with the player, which starts the spawning of the first wave of enemies. The spawn triggers are all set up to control the spawning of the enemies. This will be shown in more detail later in the video. The first enemy follows a duplicated spline path until it reaches the end, where it destroys itself and then cleans up. The second enemy follows a duplicated spline like before, however they attack firing a projectile directly downwards until they die or reach the end of their spline. The third enemy is the same as before, following a duplicated spline, but it fires projectiles that track the player's position until they reach within a certain distance, in which they stop tracking the player and proceed in a straight line. The last enemy is the boss, which has massively increased health and periodically fires a large circular blast which deals increased damage. The boss has a health bar which is always looking at the camera to give the player a visual representation of how much health the boss has remaining. This is the spawn trigger class that is used to spawn the enemies. The blueprint is derived from a class in C++ that I have created, which is using the base class of Triggerbox. On the upper right are the properties that I have set up in C++ in order to customize the spawning of the enemies. The enemy class takes an enemy class within the current project and uses that as a template to spawn the new enemies. The next feature is the option to use a random spline. In the game there are 8 pre-configured splines, as shown in the video. These are the splines that are used when the new enemies are spawned. The new splines that are spawned duplicate the points that are on one of these splines that have been selected. The random spline boolean generates a random number to select which one of the splines to use instead of using a selected spline, which is shown by the spline actor here. The spawn actor location refers to when the spline is spawned and where its spawn location will be. The movement speed is what affects the speed of the trigger when it advances towards the player. The spawn amount indicates the amount of enemies that will be spawned when the player hits the trigger. And the spawn delay configures the delay between each enemy spawning. This is the on-overlap begin, so the collision event, which is on the trigger when it hits the player. First, we check if the trigger has already been triggered with a boolean trigger once. This is so the player doesn't accidentally hit the trigger box more than once, therefore spawning more than the usual amount of enemies. Then we check if the enemy class that has been selected on the spawn trigger is valid. If it is valid, then we get the World Timer Manager and create a new timer handle, and then run the function spawn enemy with the spawn delay, and it loops until it has been stopped. This is the spawn enemy function, which is called by the timer manager above. Firstly, we spawn the new enemy and then add it to an enemy spawned array. This is so we can refer to them later if need be. Then we create a new AI controller and get the AI controller from the enemy we have just created. Then, because the function is running multiple times, we only want to spawn the spline that the enemy moves on once. So we check if the spline is not spawned, then we check what the spline configuration is. So if we are using a random spline, we will use the random spline function, or we will use the spline that has been selected in the editor. Next, we take the sample spline actor from above that has been selected either by random spline or in the editor, and then spawn a new one using the same. Then, I use a find component by class function in order to get the spline reference, or the spline component reference, in order to refer to it later in the code. Firstly, we set the spline's location to the first point on the spline. Then, with the next for loop, we loop through all of the spline points on the original spline and then add them into our new spline component. We then set the isSplined boolean to true, so then we do not spawn another spline. The next task is to get the blackboard component from the enemy AI controller, so then we can set the enemy's target spline path to the one we have just created. We then set the enemy actor's location to the first point along that spline, so then the enemy doesn't have to get there, it starts immediately at the beginning of the spline. Then we increment the spawn count to show how many enemies have spawned. Next, we have the if statement, which checks the spawn count with the maximum spawn count, which we have specified in the editor. If the spawning of the enemies has reached that limit, then we clear the timer to stop the enemies from spawning and set the spawn count to 0. The random spline function generates a random number using the fmath function randRange between 0 and then the maximum number of elements in the spline array minus 1. Then we use the spline actor, get the spline array, use that random number to get which spline to use, and then set the spline actor and the spline to those values. Next part of the video, I'm going to cover the behaviour tree tasks in which the enemies use as their AI controller to follow the splines and also complete any other behaviour. While we have the constructor, which sets the node name in which will appear in the behaviour tree task. We then say bNotify tick is true, so then when we run our tick task function below, it will actually tick and not fail. Next, we have to do the bCreate node instance, because if not, all instances of enemies use the same behaviour tree task that is created instead of creating its own instance of variables and values to use. For setup, we have the execute task, which is equivalent to the begin play on an actor. We get the blackboard component from the owner component, then the owner component also gives us the pawn, which is the owner actor, which is the controlled pawn. We then set the spline path to the blackboard value, so then the behaviour tree task knows what the spline path is. If the cast fails, then we simply return that the node result has failed, so then the behaviour tree task will not carry on any further. Get the first point along the spline and store that, and then set the enemy's distance along the spline to 0. And then we set the node result to in progress, which will allow it to progress to the tick task function. Within the tick task, we check if the spline path and the owner actor exist, just so if they do not exist for whatever reason, no errors are thrown as an exception. We get the previous position of what the player is currently at on the spline. Then we use the Kismet Math library, which is a file included inside Unreal Engine, to get the look at rotation between the owner actor and the spline distance point. This way, the enemy is always facing the next point on the spline, so it looks like it's following the spline. Then find the direction of the actual movement of the player. By using direction, get the spline distance point, and then get the difference between the owner actor's location from the next point, and then normalize it. We then set the speed to 1000 as a base, use the move vector and move it over time. And then we add that vector to the original actor's location. The check for distance function checks the distance between the player and the next point on the spline according to the spline accuracy variable in the editor. The spline accuracy indicates how much it will increment before sampling the next point for the enemy to move to. For the score tracking within the game, I've decided to put it inside the game mode, in which there is a single function that adds to the player's score. So player score plus equals the add score. So when this function is called, it adds score to the score. This is the return function in which the GUI fetches the value for the player's score and displays it correctly. We get the game mode, which is the game mode class we have, and we cast it to our type of game mode. So then we can access the variable player score. But because it's an integer and it needs to be converted to a string, we have to convert it and then append the original text of score and add it onto the end, so then we get the correct text display. The video will just demonstrate game flow. So pressing the play button unpauses the game and sets the game flow going. When the player dies, they will be presented with a lose game screen, which will show your score if you have a score. Otherwise you can press play again, which will restart the current scene, so then you can play again from the beginning. Or you can choose to close the game, which closes the application immediately. To trigger from my first enemy spawning to the next one, I have a kill trigger that is behind the level, so when the enemy spawn triggers travel through, they hit this trigger and then that triggers the next trigger to start moving, which generates the game flow. I did this by having a TArray U property in which I can put every trigger inside of the properties. Doing it manually was necessary because using an actor iterator to find all the spawn triggers did not necessarily always do them in the order that I wished. Deathatron 2000 is a space shooter bulletstorm game which has the player progress through a level with multiple enemies and a boss. The aim of the game is to get the most score as possible and for the player's health to not reach zero. If this happens, the player loses the game. In order to win the game, the player must defeat the boss at the end of the level.